The most exciting part. All right, guys. Anything else? Any other?
Can we go over number 36?
Yeah.
Number 36 now.
There it is. All right, let's see, 36. I'm guessing you mean from chapter 1?
Yes.
This here, is that right?
Yeah.
Oh, shit, let me do this. Sorry, all the lights are gonna come down. And then this one is gonna go away. If it knows what it's good for. Damn it. Okay.
Probably one of the teachers that knows how to do that, you talk to.
Yeah, and then the next room over, it didn't work. So I called the stupid people, they're fine. People that should have done it before, but they didn't. They came and programmed it. So if you have a teacher go, oh yeah, you know that second button, just hold it for a second there. All right. So what's up with 36? What went wrong? What part of it either doesn't make sense or?
I didn't know how to start it.
Oh, let me ask you this. Okay. Let's go here. Let's build up to that weird ass question. If I said, can you solve this? What would you do? Yes. Do it again. Yeah, beautiful. If you change it in an exponential form, what does that mean to do that? What base are we working with here? E. And you know, like the letter pi represents a number, and the number's special because any size circle you take a circumference divided by diameter, you got the same damn number. Freaked civilizations out, so they gave it the letter pi. E comes from Euler, and it's not because his last name starts with an E, but because he was on that letter of the alphabet when he was investigating weird ass numbers. Later this semester, I'll show you one of my favorite places where E comes from that you don't even understand is in calculus. That was a log. I'm sorry. That is log base E, and we short it to be natural log. There's dumbass math jokes about natural log cabinets and so forth. I don't know if any of you have heard those. So this is base E. So base to a power equals the inside. Base to the power equals the inside. And then you'd be done. And you're like, good for that problem, Jeff. That's not the problem you assigned me, math boy. Huh?
It's the same pretty sure there is a question like that.
Oh, beautiful. So that builds you up to it. Yeah, 32's like that. So it's got one extra step, but it's okay. So let me ask you this. What if you had this? What you got, Jeff? No, God, no. It doesn't matter, Jeff. It's fine. There. What would you do then? Yes.
I'd say start with we combine like.
Yes. Well, no. What do you mean combine like terms?
Or combine the logarithm.
Yes. So use log problem. If I had one log, like the first problem, easy. This has got multiple logs. Yes. So then I'm going to put them together to a little structure. How can I put these together?
You have to distribute x to x plus 2.
Yeah, because when you add powers, because a log is a power, that means you are multiplying the things. So the log plus log becomes the log of the product. Now I've got a single logarithm here, yes? So that would be base to the power equals the inside. Now real quick, I made kind of a gross problem, but not really. How would you solve that? Is anybody super psyched about solving that?
Taking the X's out.
Listen very
Put them
carefully.
together.
What are the only two, what has the answer got to be to a product to know what one of the numbers has to be? Let me say this better. If I told you two numbers multiply be 8, Do you know anything about the two numbers? Neither one can be 0. That's the only thing we know, right? Does either one have to be positive? No. Right? Does either one have to be 8? No. Are you guys at all with me? The only way I know something about the product is if it equals 0. Because then what must one of them have to be? 0. The only way to multiply two things have 0 is 0. Right. So that's not 0. So what do you do when you have a power on your variable that's higher than 1? How do you solve an equation? We're not going to bring back in the thing that was in our way in the first place. Yeah. We killed the log. Let's not bring it back.
Right.
Little zombie log comes up. What that looks like.
Okay.
It bit me. Turn it into a tree. So, what do you do when you can't factor? Because I want to make this equal to 0, don't I? I have to make this equal to 0. So what am I going to use? Because can you factor this thing? Can you factor this? So what do you use?
Quadratic.
Quadratic formula.
Okay.
Yes.
Alright.
Right, that's its purpose. That's why it exists. We found. Does anyone know where the quadratic formula came from? Besides the fever dream of a math person? We took this equation, this equation right here, and we solved it. Because we are insane. And if you had a decent math teacher, they would have shown you how completing the square gets you the quadratic formula. So it comes from somewhere. We didn't just go, let's do this so students have to plug shit in. No. If I solve that for x, I get negative p plus or minus square root of blah, 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 blah. Yes? Are you guys okay? I pushed that one a little further than we have to worry about. But so that's exactly what you do. You get your natural log stuff together, use properties to put them together. I think on that one you're going to have a minus, right? Because you're going to subtract one of the logs, and then you're going to want to make it into a quotient, blah, blah, blah. Yep. Okay. Yes, maybe, no? Screw you, Jeff. Make some sense, Jeff. Have you considered making sense, Jeff? Hey. Now this semester I'm just going to push my luck and just keep saying weird shit till somebody says something. Every semester I do. I'm a math teacher. I say weird shit all the time. Anything, is that okay? That problem is okay if you have follow-up questions? Yeah.
I was hoping to take a look at source message like 34, 35. It involves inverse function. And
Oh, these here?
yeah.
Okay. 34, 35, the first step is exactly the same. On 34 and 35, the first step is exactly the same. And in fact, it's the exact same step that you would take if you tried to solve this. How do you solve a problem like Maria? Now, how do you solve this? What would you do?
You raise everything to both sides to the power of 3.
Beautiful. He just said you operate on both sides with the inverse function. That's what you said. Because what's the inverse of cube root?
Oh, I see.
Yes.
Okay.
So if your x is stuck inside of stuff, if we can, what do? We apply the inverse function so the outside stuff dies. It's like a jailbreak, right? This x, somebody put him in a little cube root jail, so we put a little cube bomb there, boom! All right, that's what happens in my head anyway. I don't know. X breaks out, cube root's dead. All kinds of ethical implications there in the solving of equations.
So you're saying for 34, you have to take the first word?
Yeah, totally. So what really kicks ass about these two is the inverse function's there. So what is the inverse of the inverse? What's the inverse of cosine inverse? Cosine. Yes? What's the inverse of cosine? Inverse cosine. What's the inverse of inverse cosine? Cosine. They are each other's inverses. What's the inverse of cube rooting? What's the inverse of cube rooting? Cubing. What's the inverse of cubing? Cube rooting. So if you know something's inverse, you know that inverse is inverse. It's the original thing. Is that okay? They go together. They're a little pair. So for 34, how do you kill an inverse cosine? You operate on both sides with the cosine. Does that make any sense?
So that would be-
It's exactly what we just did when you told me to cube the damn cube root. Why did you tell me to do that? Weird people, why did you tell me to cube this?
So you can get rid of.
So these die. So what happens? Here, we'll do this one together. What's the opposite? What's the inverse of the inverse cosine? Cosine. So if I take cosine of both sides, I did not multiply both sides by COS, right? I took cosine of both sides. What does cosine and inverse cosine do to each other? What do these do to each other? Same thing these did to each other for the exact same reason. They're like matter and antimatter. So thankfully, your paper doesn't explode in some huge amount of energy. Not yet, though. There's some spontaneous combustions. They were killing inverse function. Sorry, I'm sorry. I go off on this. So, are you guys okay? I need you to start to see how a lot of what we do in mathematics is generalizable. Oh my God. I don't say that word too often. You gotta be really careful what you generalize, but the idea of solving a function by applying its inverse is something you've done since the very first day you learned how to do x plus 2 equals 7. What did you do? You applied the inverse. What's the inverse of addition? Holy shit. I mean, that's what you've been doing. Will that always work when I'm solving it? No, of course not. No, it won't always work exactly that way. So what do? Why did I make this here? Just to really true. Back here when we did this, why did we put those together? So that I could apply the inverse. Does anyone know what the inverse function of natural log of x is? What's the inverse function of natural log of something? You could do it. Every logarithm is the inverse of what? Exponential. So natural log is the inverse of e to the power. You guys with me? Log base 2 is the inverse of 2 to the power, blah, blah, blah. So watch this. The shortcut is to go base to the power equals inside, yes? And that's how we got this. Is that cool? Is everybody cool with that? You better, because you didn't say anything earlier. So if I look at this again, I'm not saying you have to do it this way. Oh shit, especially if you can't see it. If I apply the inverse function to both sides, so I'm going to raise e to both sides, these kill each other. That is actually a better explanation as to what the hell is actually going on. Am I just remembering how to rewrite it, or am I actually doing shit? Yes to both. That's the shit you're doing, or you just remember the shortcut base to the power equals the inside. Is that? Okay, maybe. The more you start to realize math is a collection of all these basic operations that don't change, then you have less to memorize, right? Okay. If I had to memorize everything I could do, I'd be in the corner somewhere battling, because I would have forgotten all my everything. Yes, start. 21. Oh, okay, yeah. By the way, I kind of wore this shirt on purpose because I want to stave off some things. Do you see on number 21, does it say anything about graphing them? On 21, does it say anything about graphing them? No, it doesn't, so don't. You can't graph these on your calculator and get the answer. It's not the point, yes? So what I like to tell people is, if you do that, then your calculator passes the class, and you don't. Your calculator goes on, has a nice life, has little calculator babies, and you're stuck taking this class, yes? Okay, that doesn't say a damn thing about calculator, yes? It sure as all hell doesn't say a damn thing about photomath either, so just remember, I know photomath exists, so just to stave off anybody from doing that. I know what it looks like. No, ChatGPT sucks. Huh?
Oh, sorry, I didn't realize it's one number 21 asked.
Oh, yeah, you're good. Okay, so you're asking about 21b? Okay, and real quick, do you know what these symbols mean? Besides, this is often how people feel they're in when they take comments. What's that little symbol mean, the little O?
Positive G.
What?
F of G.
Yeah, F of G. So you can just immediately rewrite that as f of g of x. So that g is inside of f. So look at part B. It says g of f. So what does that mean? What does it want me to do?
Find f of x. Look,
Well, we know f of x.
find g.
Put f of x into g. So in place of the x in g, I'm going to replace it with that function. Yes? Is that okay? And then it asks you, what's the domain of that? Now that one gets interesting. A little bit, not too much. I don't know if that was what the question was really about. Was it a domain question?
Yeah, you made the question.
So help me out, guys. Does anyone know what the domain of natural log of x by itself is?
It's like everything is a zero.
Huh?
Plugging some giant lines of everything is zero. Because we can compare it.
What is natural log asking you? Like if I say natural log of 3, what is that asking you? E to the what power is 3? Now guys, help me out. Can you start with a positive number and raise it to a power and make it become 0? Let's start with 5. What's 5 to the first power? 5 squared gets bigger, yes? 5 to the negative 1 is 1/5. 5 to the negative 2 is 1 over 25. 5 to the negative 18 trillion is 1 over 5 to the 18 trillion. Is that 0? Is that really close to 0? But is it 0? Hell no. The only way a fraction can be 0 is if the top is 0, and I don't care how big you make that negative number, the top is going to be 1. Yes? 1 over 5 to the blue. You guys all looking? So what does it see? The natural log is not able to give me as an output. 0. And if it can't even get to 0, it definitely can't get to negative numbers.
So that's
So this is where you guys, and again, I can't remember where I'm wearing my dancing function shirt. I don't know if I wore it for you guys. Maybe this Wednesday I'll wear it for you guys. You have to know what the functions look like. What does an absolute value function look like if I graph it? Does anyone know? Yes, a v. Because it's a first power, so it's linear, but it can't be negative. So it does like a parabola and turns, but for a different reason. Still linear, but it turns, yes? And of course, parabola, we all know a parabola and a cube looks like, square root looks like a parabola that fell out and lost its bottom half, yes? Yes? Okay. So, natural log looks like what? Yes, okay, I like it. Although at the end there it went a little crazy, but natural log looks like, wee. It's got a little asymptote here, I could put a little Gandalf. You shall not pass. Okay. So, I had that shirt. I have the shirt with Gandalf, and if I wear it though, people take it personally, and I'm like, no, this is just a joke about the asymptote. So read with me. So if you know what a function looks like, you know what its domain is. It's even better if you know why its domain is that, but that's a quick way to go, oh yeah, its domain starts at 0 and it doesn't include 0 because there's an asymptote there, yeah? Is everybody with me? Yes?
Well, I do, so, in the spirit of showing our work, if you memorize what a function looks like and therefore its domain, when you write it on your homework, do you want us to?
Just draw a little picture real quick.
Oh,
It looks like this, yeah. Don't graph it in your graphing calculator and then come from that.
Right, but
Yes.
we don't have to algebraically, like,
Not for natural log. No, because it's, or you can argue. You don't have to graph. You could just say, well, I can't even get a 0 out, so therefore, blah, 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 right? Okay. So this goes from 0, do I include 0? No. To infinity. And you never include infinity. Now, what about this? What if I had this here? Does that affect the inputs at all? What am I squaring? What am I squaring? Natural log of x, yes. So that affects the outputs. Does it affect the inputs? Still has the same problem, don't it? What about this? So that domain is the same. What about this? You see the difference now. What am I squaring? X, and domain is all about x, so the domain's going to change. Potentially, and it does here, because now what am I allowing as an input that I couldn't allow before? Negatives, because what's the first thing I'm doing to my input? Squaring it. So now I'm allowed to plug a -1 in, because -1 squared is 1 and natural log of 1 is 0 is fine. So what's the only thing this can't handle then? 0. Because the original couldn't handle it. 0 squared is 0, so it still has a problem at 0. Anything else? Which one? 25. Oh yeah, this one. Oh, this one's so beautifully evil. Alright. I don't blame those of you who have tried to do work on this, but it actually is just, can you very quickly see? I mean, what is f inverse of 6 actually asking in relation to what they've given me? F inverse of 6.
Plug in 6, but the inverse of it, right?
True. And what does the inverse do to the inputs and the outputs compared to the original? Switches them. So f inverse of 6, the 6 is the input for the inverse. It actually means when is 6 the output of the original. So can you guys just by sight see an input that would make the output 6? 1. So that's an example of a problem where you really don't have to do any work. You just have to say, well, it's really, can you interpret what this means? And then can you just see how to answer what it wants? It wants an output of 6. You go 2 plus 4. Wait, 1. Bam, done. Okay, I like it. When in doubt, show work. But there's going to be quite a few problems where there really isn't a lot of work to show. And the more you understand what you're doing, the more you're going to know when that's required and when it's not. Okay. So there's a freebie. Anything else? Anything we haven't talked about yet? Okay. Alright, has anyone gotten to chapter 2 homework yet? Alright, I like some of you guys looking at me like I was crazy. No. Okay, so I think we left off. So let me come back. Last time we did that handout, we did this sucker here. Let me see if anybody needs one. Pretty sure at least one person does. Do I have any extra? Jeff? Okay. Well, shit. Oh, here we go. Does anyone need one of these? Yes? Do I have more? Yes. Oh, shit. Okay, wait. What happened? I have more. I have this many. Okay. Which one is it? This one. All right. Oops, sorry. Do it again. Shit. I know you were here last time. No, you were right there. No. I wasn't here last time. So I'm going to focus on it. How are you? Oh, okay. All right. All right, well, here. I printed out more than I should have needed, but somehow, yeah, this one's got many. All right. If you didn't get one, then see me after class. Sidle up next to somebody that has one. If you want to look on with them. Make sure not. No. Nope. That's never got it. So I think if you weren't here last time, there's the video where we go over all this business. So in order for a limit to exist at a point, what must be true? For a limit to exist at a point, what must be true?
They have 2 points on both sides.
Yeah, they have to both agree on where it looks like they're going. Do they have to actually get there? The limit is all about where does it look like it's going, F of input is all about where is it? It doesn't even know how it got there. So on, sorry, I only have this copy now, that's all written on. And I've hidden my, okay, that's right. Oh boy, this is written all over. So like, this one here, the limit's fine, and the function value's fine. They just happen to not agree with each other. Yes? So that's the one where I said there's a pothole on the road and the people came to fix it and they missed? Okay. Okay. So we finished this side last time. And I think we did the first two here, if I remember correctly. Oh yeah, before I forget, 2:30, I've got somebody to talk to you guys about success coaches coming in. Does anyone know anything about the success coach program? Anybody? You guys, some of you guys a little bit? Okay, she's gonna tell you about it. It's the best program on campus, period. Because it's the way to get you connected to any program you might need, is through them. It's silly, but they'll talk to you. Huh? Yeah, I don't think we did part C, right?
No.
Okay. So what's the idea behind this kind of problem? If I just said evaluate this limit, what's the very first thing you do? No. I appreciate that. That will be what I will do. That's my second step though. Because the first step is going to tell me if I actually have to do any work.
Oh, plug in too.
Plug it in. So let me do this real quick, guys. Let me give you an example of a problem I will give you on a quiz, on a test, on both, all over the damn place. Sure. Now, unfortunately, what students do is they'll just start factoring, which to me is actually good. Like any practice you can get with that, it's completely unnecessary. It's completely unnecessary to factor this. Why?
Because you're not getting zero on the bottom.
Yeah, when you plug a 2 in, on the top you get 0, but on the bottom you get no. What do you get on the bottom?
8.
Yeah, you get 4, plus 6 is 10,
Oh,
Sorry, I was looking at
plus
the-
2 is 12. I'm sorry, I'm doing like a side note here. You guys, I really need you with me. What is it that tells me I have more work to do if it's indeterminate? That literally means I currently cannot determine the answer the way it is, so I have to change it. If it's not indeterminate, that means it's determinate, which means you should be able to get the answer. You can determine it. Okay, so this is not indeterminate. In fact, what the hell is 0 divided by, what did I say, 12? What? Freaking 0, you're done. Yes? So, that's why the very first step in any problem, I don't care if you see how to factor it, I don't care if you see its conjugate, you don't even know if they'll worry about that. Maybe you plug the number in, just the number, and you're like, sweet. Is everybody with me? And now I've told you, I'm going to put a problem like that on the quiz, on the test, blah, blah, blah. By the way, I keep saying quiz. We're having a quiz this Wednesday. You're welcome. On chapter 1, 2.2 and 2.3. Yes,
Can I get another paper?
do it again.
Can I get another paper?
One of these?
Yeah,
These handouts?
yeah.
I'm out. I'm out. You can come afterwards to my office. Even though I printed like 5 more than I really needed, somehow they were gone. So, okay. So everybody, so quiz Wednesday. Because what's happening Monday? A week from today. What's happening on Monday?
Labor Day.
Yeah, it's a holiday. Don't come. The whole college is shut down. What's happening that Wednesday after that? A week from this Wednesday. This semester, Jeff. Every day's Labor Day. Have you heard? I'm like, damn, this is gonna be rough. We're gonna have to take your final this Wednesday. You ready? You, just, okay. When's our first test? Let me start like that. Hmm? I'm not asking where you want it to be. I'm asking to see if anybody knows where it is. Because I know where it is. September 8th, which is a Monday. So 2 weeks from today is our first test. So bear with me. There shouldn't be groundbreaking, earth-shattering news, because I told you before the semester started. Right? Okay. Next one is a holiday. So next Wednesday is review day. Which means next Wednesday I'm not going to do anything new. We're just going to review. This Wednesday I'm going to give you the practice test. I'll have an answer for it on next Wednesday. So bear with me. Yeah, so what's the only time I can actually give you a quiz? Either pop quiz today. I didn't want to do that shit. Or a quiz once. Yes. And has anyone been in college long enough to know you want more grades? Real quick, yes? You want more grades. If I feel bad if I don't give you enough quiz, I feel bad I'm only giving you one quiz for the first test. I had a class where the only grade was the oral final exam. He put us each in our own little room, and my friend Sue had a nervous breakdown in the room next to me. And he's just like, just keep working, Jeff, I'll be back to see you. I'm like, working? And she's over there, oh! I was like, shit. Anyway, she retook it later, she's fine. Wait, I'm sorry. You guys with me? You want more grades, okay. Okay, after all that, let's come back to this. So I really appreciate somebody, and I think we did say a little bit about this. What'd you say again? You should get. No. For the top. Why do I want to do that? Because if I have one fraction divided by shit, I know that's one fraction times 1 over shit, yes? So if I can make the top one fraction, I know how to do it. Now, is this the only way to do it? No. But it's probably the cleanest, most direct way to do it. So can you guys go ahead, combine the top? You're in calculus, so nobody better freak out about there being an X down there. Or if you are, just let me know. It's okay. If you don't want to do it, I always tell people, draw a duck or something. I can't tell the difference from over here. Preferably do the problem. So you look at the numbers, we look at the variables, you give everybody what they're missing. So what is the LCD for the top? What's the LCD for the numbers?
2.
What's the lowest common denominator? If one of them is a 2, one of them is a 4, what can they both multiply up to be? And the option is you can multiply something by 1. Yes? What is it? What's happening right now? Are you guys okay? This is nothing. This is not a gotcha moment. This is not a trick question. If I was doing 1/2 plus 1/4, what would the LCD be? 4. 4 would be the LCD. Okay, I like it. Yes? Okay. And then what do they both also need that one of them has? An X. So 4X. That's how you look at it. Look at the numbers. Look at the variables. Yes? They both need a 4, and they both need an X. So what's the first dude need? What's he need? 2. So multiply him by 2 on top and bottom. What does he need? X. So multiply top and bottom by X. So then I get 2 minus X over 4X over 2X minus 4. Is that cool? Is that right? Oh man. Okay. Gotta find my people that will do the information. Okay. What do I do now? Go team! We did it. We put the top. We made one big ass fraction, and now it looks worse. Thanks, Jeff. But what can I do now? I got a fraction divided by stuff. How do I do that? How do I divide fractions? Multiply by our number bar. Yes. So this will be 2 minus x over 4x times 1 over 2x minus 4. Now don't distribute the 4x because what do you look for before you multiply two fractions? You look to see if anything cancels. Can you factor stuff so that something will cancel? How can you factor the 2x minus 4? Take a 2 out. What are you left with? X minus 2, yes? Isn't that almost what this is? What can you factor out of him? So I have I'm going to leave the top of that blank. If I take a 2 out of here, I have x minus 2. What can I take out of him to make him the same as that? Take out a negative, like a negative 1. What cancels? What piece of this, and by the way, notice this, what piece of this does not allow me to plug a 2 in? Exactly the piece I'm about to kill. And again, not a life lesson. That's how these kind of problems where you have like polynomials or rational functions or so forth, if I'm taking a limit and it's indeterminate, I should be able to get to a point where I can kill the piece that's making it indeterminate. 0 over 0 is all this guy's fault. So if I kill him, now what happens when I try to plug a 2 in? On the top I get negative 1, what do I get on the bottom? 4 times
8.
8.
Sorry.
You're good.
My brain is off
You're fine.
today.
I can
Adding
so relate.
numbers wrong.
Huh?
I said I'm adding numbers wrong.
No, you're fine. You're at least
Multiplying
give me an
numbers.
answer. I'm happy about that. Wait, did I do that right? 16 it should be actually. You were right the first time.
Okay.
I'm going see. That's a beautiful
Well, I was talking
example.
about the addition earlier.
So this is 8, and then times the other 2, Jeff. So you should expect a lot of these, if it's indeterminate, and it's like, and then you're going to see a lot of rational functions, you're going to see a lot of like conjugate problems where you have the radical stuff, yes? If it's indeterminate, and you follow the process I've told you, you'll end up killing the part that's not letting you plug the number in. You can see, those were the parts that were making it so I couldn't plug to it. And we just got it to a point where we got rid of it. Now I can plug it to it. So what do you do when you have a radical expression like this? Conjugate. What do you do when you have just beautiful little polynomial stuff? You try to
Pull out, really.
factor. Yes? And what do you do if you have fractions inside of fractions? You put them together, multiply the reciprocal. Those are the worst, of course. They always are. Okay. How do you guys feel about that? So, if you have issues with remembering how to factor, I'm pretty sure I put like a factoring worksheet up in our Canvas. You gotta hear me out. If you go into any further math, including this class you're in right now, you gotta know how to factor. It's gotta be right there, because it's gonna come up a lot. Why? Because it does. It's one of the most fundamental things in mathematics. It's like not knowing how to add two things. You're not gonna get very far. Yeah. So if you have any trouble factoring, let me know. Okay, so now let's talk about this thing, and let me remind you. Well, let's see. Yeah, let's just tackle this directly. I'm not going to try. I want you to notice though what this problem is doing. Maybe I will remind you a little bit. Do you remember the very first thing we started with was I'm trying to get the slope at a point, but algebra freaks out if I only give it 1 point. It's impossible. I have to have 2 points. So then how do I kind of like compromise? I pick a second point, but then I let that second point get closer and closer, yes? And eventually we're going to make that into a limiting process, which we now understand limits exist by themselves. The reason I don't like, well, I don't like doing 2-1 first, because then it makes it feel like all the limit stuff is just for this. This is one thing we can use limits for. Okay, so 2-1 needs us to create a table, like we did on the other side. So let me ask you this. This gets a little bit silly. We don't have to make a table for this, to be honest, the way I've set this up. Do you see what I'm doing? Why am I doing this? Why did I pick those numbers? Getting closer to 3, which is the point that I'm interested in, yeah? And then I'm getting, what is this all about? Why did I do this weird shit? Because for the limit to exist, it's got to exist from both sides. So I have to see if both sides agree. Okay, kick ass. How do you find the slope? What do you need? Just the most basic way to find the slope. I have to give you 2 points. Don't we have a point already? What point do we have in every one of these problems? What point do we have? 3, 1. For this first problem, what's the point? How do you get the point that you have to work with on that first problem? Yeah, I've got an input, just plug it in. So go ahead, plug 2.5 in to the function I gave you. So we got the point 3, 1. And I'm just getting the other point. And then on part B, I'm gonna let that get closer. And then on part C, I'm gonna let that get closer. Yes? So I keep getting this slope that's slowly getting better. Okay. So plug that in. So what do you get when you plug that in? You do that, huh? Or if you just plug in your old calculator, you should get 1.333. Yes, anytime you have like a 0.5, just double the top and bottom, get a nice whole number thing. Okay. Do I have 2 points now? What are they? 3, 1, and? No, careful. What was the input? 2.5, 4 thirds. Or 1.33, it's up to you. So can you get the slope now? All right, keep doing. Keep going. Finish it up. Go with it. Find the slope. Not even recording, poor little guy. Oh no. I'm sorry. If you're home. It's finally lost it. So now I get the slope. Difference in the y's divided by difference in the x's. So I get 0.2 divided by negative 0.5. 2/5 is 0.4. Negative, John? And then, I just keep going. 3, 1, and when I plug a 3.1 in, I'm going to get 2 divided by 2.1. Yeah. So big ugly thing, so we're just going to do 20 over 21. Let me stop for a minute. Somebody, you can see it's the same thing over and over. I'm just doing the same process, which is an algebraic process, but I'm doing it in a pattern, getting closer to the desired point. Because that's the best we could do. I can't plug one point in and get a slope from it. So calculus says, all right, just start getting closer to it. And then, remember, this is section 2.1 before we officially talk about limits. So I'm still using that, but then later we can just apply a limit to it and get a precise answer. Here we go. So then the slope would be 1 minus 20 over 21 divided by 3 minus 3.1. Should be, what is that? 10 over 21, which is 0.476 negative. 19, blah, blah, blah. So you can see it's already starting to do what we thought it might. It's starting to approach negative 0.5. Yes? Then, you're not going to believe this. We do the same shit. 3.01. When I plug that in, I have no idea. Oh, Jeff. I get 0.995. So, like, you could do it, Jeff. What is it going to be? 2 over, it's going to be, yeah, Jeff, it's the same pattern. 200 over 201. So that'll be 1 minus 200 over 201 divided by 3 minus 3.01, which ends up being, what do you get, Jeff? Let's see, that'll be 1 over 201, negative 100. I think it's negative 100 over 201, which is almost freaking 1/2. Negative 0.4975. 1, 2, blah, blah, blah. Okay, so I need you to understand. You're going to understandably come to dislike a lot of the problems in chapter 2, not because they're hard, but because, do you guys see how you're doing the same damn thing? Sorry. If you go back and look at the homework I assigned, did I assign a lot of homework out of this section? Out of this section? No, I assigned like 5, 6 problems, I think. That's why. One problem is this, yes? Yes, kind of. Okay. But this is important. You have to know what's going into, concretely into the stuff we're doing later with just the limit symbol. Okay. So what's our guess? Yeah, from both sides, it looks like it's approaching negative 0.5. Could the answer actually be negative 0.5? Oh, 1, 2. Yeah, but we're just humans. We're going to do our best. That's why
It's an arbitrary statement. It's approaching that point.
it looks to be, from the limited information I have. How many more inputs would I have to do to get it exactly right? An infinite number. I'm not going to do that. I'm going to go, it looks like it's negative. Which is why we talk about the algebraic ways to evaluate limits. Okay. Do you guys understand the work that goes in? It's predicated on y2 minus y1 over x2 minus x1. So for a lot of the problems in section 2.1, you just have to figure out the second point in each step. You have one point, and then you have inputs that lead to the second point. Blah, 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 blah. Okay. We're going to look back at this problem when we're like in section 3.2, and then you guys will know how to do this a different way, the calculus way. We're still sort of like one notch above algebra. So, what I want to focus on today, I think I'm going to do this in reverse order of what I normally do. I think that makes sense. I want to talk about something that's come up a little. Oh, shit, before I go too far, let me show you this. Okay, that's what I did wrong. Oh, no, that's got to be 3. So let me do something here. All right. And then let me make this negative. All right, so real quick. I don't know how well you can see this, and I can't really blow this up too much, I don't think, but my input that I'm curious about is 3, 1, yes? I don't know why I could bring the scale back, I think. And that is the point 2.5, comma, whatever the output was. So really, that's the point 2.5, 4/3. That's why it's a little higher than this one, because that's 1. This is 1 and 1/3. Is everybody with me? That's that part A we did just now. Isn't there a slope between those 2 points? Yes. Which one do you want, Jeff? I want this one. That's the slope between the 2 points. Do you see how H, we're used to H by now. We understand what H means. That's just how far away I got from the point, yes? So it's negative right now because I'm before it. So as I get closer, 0.1 away, that's when we did 2.9, because that's 0.1 below 3. Do you see how the slope has changed? It's, what did you just do, Jeff? There you go. Slope is bigger negative here, now it's smaller negative, correct? And that's exactly what we saw. It was negative 0.52, and then it was negative 0.502. Yes, it got smaller and negative, smaller, negative. Okay. And of course, when I swing to the other side, what did we get just now? Did we get negative 0.4, that first answer? When it was 3.5? And then if I get closer, just 0.1 away, that's negative 0.476, and then when I can't get within 2 decibels, unfortunately, for this thing. So here's the neat part. That is the real slope at that point. And you can see as we swing ever closer, we continue to decrease the error between our guess and the actual slope right there. Now watch what happens if I make this right on it. It should freak out, become a 0. Jeff, the red line goes away, undefined. Yes? Does anyone see, if you've done any calculus before, you know what that symbol means right there, F with a little line on it? If you haven't done calculus yet, that's fine. This is exactly where you want to be. You don't know what the hell that means, but that's going to be a shortcut we're going to learn in chapter 3. Okay. Because do you want to do this forever? To figure out the slope of a function? That would suck. Okay. So let's do this. I want to go back. So that was section 2.1. This is an example of the work you're going to have to do in section 2.1. I want to go back to this side, and unfortunately I only have this crappy version, but I think I said a word a few times, potentially. How would you describe this situation here? If you're following this, what are you doing? Like if this is you're playing a video game, a platforming game, you're walking, your little dude's walking along, what's gonna have to do here? He's gonna have to jump. And that's exactly the name of this. And this location is where this function is discontinuous. So you have the idea of continuity. What does continuity mean? Continuous. So if you watch any shows, you talk about continuity. If a character doesn't like carrots in season 1, he better not suddenly like carrots in season 3, or else you're like, what is this shit? Is this an alternate timeline Marvel bullshit? You guys kind of with me? Okay. Continuity. So like this function is, that point right there, it's continuous there because it can go straight through it and it keeps going. It doesn't have any breaks. It doesn't have any jumps. So this is one kind of discontinuity. Is a jump discontinuity. That is the actual name of it. What about this one? Could, if this was a road, and this is from above, there's no connection here. Maybe there's a big canyon. You can't do shit. But can I do something about this? Could the city do something about this? What could they do? They could fill in the hole. Would the problem still be there? No, they will have removed the problem if they do that, yes? So, you're not going to believe this. We call this a removable discontinuity. Over here, they tried. Yes, they tried to remove it, and they missed. Okay. There's another kind of discontinuity you've seen. It actually came up earlier. Somehow Gandalf is associated with it. You can have this kind of discontinuity. So you're not going to believe what we call that. I mean, what's this going to? Coming from? Infinity, so that's called an infinite discontinuity. Okay. Okay. So let's formalize what continuity seems to mean. Why, it's really, really in your face why this is discontinuous, but can somebody reference limits? Why is this discontinuous? Like, all right, let's try it this way. Why is this continuous at this point right there? Why is it continuous there? Not only are you approaching the same place from both sides, but you actually get there. You guys kind of with me? So a limit doesn't care what happens at the point. To be continuous, I have to be able to drive through it. So we care about both, don't we? We care about, is it going to the same place? So once I drive through it, can I continue to drive? Or is the road here suddenly? And like, let's, well, shit. Yes? So here's what's really neat about continuity, the definition of continuity. By the way, this is section 2.5. I'm going to come back to 2.4 after talking about this. Continuity for a function f of x to be continuous at a point a f of a. I gotta be more careful. At a point x equals a. I can say this in one statement, but I'm gonna break it up into three after that. So here's the one statement I can say this in. The limit as x goes to a f of x. I'm gonna stop right there. Let me see if you guys can fill it in. What did you tell me? First off, the limit has to exist. So that means that limit statement has to actually equal a number. And in order for it to be continuous, as I go to a, my limits better be approaching the actual output there, yes? So what should this be approaching then? Not a. What's the output at a? F of a, yeah. So the fact that this equals a number, that means the limit exists. So obviously f of a is not allowed to be infinite or something. F of a's got to be finite. The fact that the limit is a number means it exists. And the fact that the number it equals is the function evaluated there means that everything agrees and it can go right through it. Let me stop for a minute. I love this idea. It's so in your face about, for it to be continuous, the two things have to agree, the two ways. Does it look like it's going to the same place? And does it actually get there? Those are the two separate kind of ways we've looked at graphs. What's the limit doing? What's the function value doing? Yes? Those two equal, continuous. So the three statements, the limit as x goes to a of f. What's the three statements? I can't remember. Let's see if I get three. Must exist. So let's say it equals L with L finite. 2, oh, I think I wrapped up two statements in one there. Oh yeah, f of x must be defined at a. 3, the limit. Here's the funny thing about the third statement. No, Jeff. It's basically the one statement. Okay, so sometimes you'll see continuity defined like this. And the weird thing is that last statement actually says these two already. Can you stop for a minute? So what does it take for a limit to exist at a point, at an input? Careful. I just said a magic word that's exactly opposite. They both have to approach the same thing, yes? From both sides. And there could be an open circle, it could be closer, it has no idea. In order for a function to exist at an input, it has to have an output there. That's not infinite, yes? So then if you just marry those two things, you get continuity. I like it. Okay. Yeah, let me do this then. Let me see if you guys really get this. There really isn't a lot to continuity. Oh, that's right. My printer was taking forever, so I have to run back and get those handouts. I'll be right back. I got a continuity handout. I'll be right back. Let's see this up. reminders on one of this so I don't forget anything. Do you guys recall, we talked about this already a little bit, these kind of functions? So like if I said, what you got, Jeff? Ooh, that's gonna get gross. Yeah, I like it. There. That's so yummy. If I ask you to graph this, all you would do, I tell people make a table of values for anything up to -2. Right? So, if I said what's f in -1, where would you plug -1? Which definition? This function seems to be defined in two ways, but not really. Just another definition takes over. So where in real life do we see this? We shoot a missile at something, some meteor, yes? When it strikes, doesn't the meteorite's trajectory change?
Yeah.
Hopefully. So I have one definition of its trajectory, and then a time, whatever it is, when the missile strikes. Hopefully this kind of like goes some other way, yes? Does that make sense? So that's like at -2, whatever, something changed with whatever this is defining. If I said what's f in -1, which one do I plug it into? The bottom one, because that's for greater than or equal to -2, yes? Okay. So we're gonna graph this. You just have outputs that come from this for inputs less than -2, and outputs from this for inputs greater than or equal to -2. You do have to plug -2 into this, believe it or not. Why would I do that? Am I allowed to? Am I allowed to plug -2 into this? Because it's not defined this way at -2, correct? But how do I know where to put the open circle? Unless I plug that in. I can see where it wants to be. Okay. So listen to this. Do you guys think cosine is continuous everywhere? What does cosine look like? You guys know what cosine looks like. What's it look like? Don't do C, O, no. What does cosine look like? Yeah. More specifically, it looks like starting at 0 looks like a octopus thing is. And it goes forever off, yes? Does it have any discontinuities? No, so it's continuous everywhere, correct? What about x plus 1? Any polynomial. One reason we categorize things as polynomials is because then I know it acts nice everywhere. It's continuous everywhere. It's got some number of terms. It looks like some kind of weird Loch Ness monster thing. Yes? No? Okay. Where's the only place that this function, and there's only one function, I've only written one function up here. Where could it be discontinuous? The only place this particular function could be discontinuous is at -2. And the way I think about it, has anyone ever seen a relay race? Somebody's running, they got a baton or a little rod thing, and they're running, and then somebody's like starts running, and then they have to hand off, yes? So the only place this could be discontinuous is at the handoff. Did it hand off correctly? Because I'm running, and then I reach back, and you're like over there. Well, shit. We lost lateral. You guys all with me? Maybe? Is that a bad choice for analogy? Probably. What's the output for -2 here? Where's this trying to be? What's the output at -2? When you plug in -2 in, you get -1. What's the output at -2 here? What's the cosine of -2 pi? Where am I at? -2 pi. From your perspective, I'm going to go back to pi. Where am I? 0 degrees. What's the cosine there? 1. What's 1 minus 2? Did the handoff do correctly? Were they at the same place? Do you guys see what I mean? Do either one of these functions have an issue somewhere? No. So the only place this could be discontinuous is at -2. Now, if I would have done this, what you got, Jeff? So you start to see you always have to check the handoff to make sure that it didn't jump or something? That they actually go to the same place, yes? But where else do I have to realize there's a problem? Is there anywhere else there's a problem? Do either one of the functions have a problem based on where they're defined? Yes?
For SMX,
I'm sorry, do it again? No, because when I plug a -2 in here, it's -1.
For the limits, it either has to be, oh wait, you put it.
Yes.
Yeah.
Yeah, okay. You're good. Now looking at G. Don't both those functions have issues? Does the natural log have issues somewhere? In general, yes? And doesn't 1/x+3 have an obvious issue? Where does 1/x+3 have an issue? -3. And am I does it allow that as an input? Less than 0 is -3 less than 0. So it does. So where's one place that it's discontinuous because the function has an issue? -3. What about at 0? Oh, I'm sorry, what about natural log? Where would it have an issue? What can the inside of a natural log not be? Negative or 0. So it would have an issue starting at -1 and going down, but my inputs have to start at 0 and go up, so it's fine. That function doesn't have an issue itself because I'm not even allowing it to have inputs that are a problem. So you always have to check, well, we haven't checked yet, the handle. But you also have to look, does any individual function have its own issue? 1/x+3 is discontinuous at -3. Can you be more precise? What kind of discontinuity is it? What happens at -3 for 1/x+3? It's asymptotic there, yes? Okay, so that would be like an infinite. So, what about 0? What do you get when you plug a 0 in here? 1/3. What do you get when you put a 0 in here? 0. Natural log of 1 is 0. Yes? Did those agree? What did we just say up here? We said 1/3 and 0. So one's going to 1/3 and the other one's going to 0. What kind of discontinuity is that? So if I said, where is g of x continuous? Everywhere except -3. Remember, where something is continuous or discontinuous is inputs. What inputs make there be a problem? -3 and 0. Because the handoff didn't work, but then the runners, one of the runners has an issue. Maybe? You guys see that? So even if I don't talk about piecewise functions, if I gave you this, how would you determine where that's discontinuous? Yes. But there's something better you can do. Why was this one so easy? And at least looking back, you should know this one's easy. Why is this one easy? Because I can see what's going to make the bottom go freaky, yes? -3 is going to make this thing freak out. What can I do to make this one just as easy? Yes. Be careful about what's what.
Plus
Nope. Bigger one's got to be. Yeah. So where is this discontinuous? 3 and -2. Does it have a discontinuity? Does it have a discontinuity anywhere else? No, it can't. The only thing that would make this freak out is at the bottom of 0, we identify both. Would you all agree it's continuous everywhere else? Any other X you plug in there, it's not going to have a problem. It's going to be a number. It's going to be beautiful. Yes? So, do you see how rational functions are continuous on their domain. Whatever their domain, what is not in the domain of this function? 3 and negative 2. And it's continuous everywhere else. So this function is continuous on its domain. And there will be a list of like different functions that are continuous. And they're all kind of like the nice function. Polynomials. They're just greatest. The nice little thing. Thank you so much. Okay, so let me let you look at this. Look at the sign that says 2-5. We haven't done 2-4 yet. 2-5. That's the one given to you face up is 2-5. Go ahead and give these a try. I won't force you into groups, but if you want to work near people or with people who are near you, feel free.
Pass out to this
I guess so.
group.
You guys want a cup? Did I give you one? Yeah. I totally wish you guys. Oh wait.
What happened last week?
Yeah, I gave you this.
Oh,
Yeah.
my bad.
This is what happened last week was I gave enough for everybody. Okay.
Oh, you took my paper.
I gave you guys enough for these guys.
Yeah, but you grabbed. Yeah, you grabbed.
Oh, I'm sorry. Okay.
You just forgot it.
I'm evil.
Oh, it's my fault. I passed it that way instead of that way.
Oh.
Yeah. I screwed it up. That was
Somewhere there's 2 extra. Okay.
Or you're finally losing it.
Oh, I lost it.
Of course, this is your profession.
About 11 and a half years ago.
What is that one in 6 called?
Where?
That's 6.
At 6. Oh, the name of the type of discontinuity. That's the one where they could have filled in. They could have done one what with the problem. They could have. There's a problem.
The key term,
Try
the
it.
key term is not
Remove. So it's removed. Yep. No. Okay, so where are there issues on this graph? Where is it? So there's no issues here. I'm going along nice and nice. Where's the first place I hit an issue? Here. So then my question is, Jess, can you identify where those issues are? What is it? -3. And at that point, what type of discontinuity is it? Is it jump? Is it removable? Is it infinite? So if it literally jumps from that to the next, it's a jump discontinuity.
Does that mean that the line for 4 and 30, does that mean that one's technically infinite discontinuity? could try to argue jump,
As
but
well, that's functionally asymptotic.
infinite trumps jump, just to use a unfortunate word.
It's not pothole, that's not your official name.
Oh, that's right. Removable. Because they could have removed the problem. She is backwards, like it answers, I mean, it should be fillable or something. But they remove a hole, that makes sense in math.
Yeah, alright. Good soil practice. Huh?
So I was doing questions and I think I don't think I heard this class
I told you in the email job at 171 class, which is like pre-calculus, trimmed down to just what's essential. So instead of being 6 units, it's 3, like a lab attached. You know, so that's an option. 'Cause it's got trig in there also. So all we've done in there so far, for me, is like factoring and functions. Like today, we're getting into piecewise functions specifically.
Yeah, I just thought.
So that's an option, but there's 3 sections of it, and mine is like 5:30 p.m. to 7:30 p.m. You can look at the other chapter, or you can take 176, which has got college algebra and trig. Right?
Yeah, because I just, well, actually, that was, like, I wanted to know what station I was in, so I don't know.
Like this, like
Because the highest class I took in high school was 2 now. Right, I had, not bad in that, it's when it's still fine, and like, even just do, you know, so I don't think, like, I think this is the class, if I can just stay in this class, I just gotta take my GPA, but this, I got, I got a lot.
Yeah.
So it's like, so I need to drop it a little bit, but I don't know how far to drop it.
Well, here's the problem. That's pretty much as far as you can drop. According to the state, they're not allowed to teach intermediate algebra anymore. They teach elementary algebra.
So 170.
Yeah, 170 level class is the lowest STEM applicable class you can take. 170 is trig by itself. 176 is trig plus college algebra. 175 is college algebra with no trig. 171 is the slimmed down version of all of that. So you can pick any of those. Yeah, but the problem is you missed a week or whatever it is. So, but the fact is you're coming from calc down. Whoever you end up choosing should be okay with you joining.
Yeah, I'm confident I can catch up with some. It's not good as what it is. Okay, so I'm gonna drop it.
Okay.
Thank you so much.
Yeah. Let me know if you need more advice on what to take.
Yeah, that would, maybe I can talk to you after class is over, or.
If you want to hang out, yeah.
Yeah, but this is on if you gotta do something correct, I don't know, bring something else.
Well, right after class, I have that CISL lab.
Right.
But you can talk with me in there if it's not too busy. Yeah.
Yeah, that's good.
Okay. Sure.
Yeah.
So, imagine, that's where these dudes go. Oh, geez, I'm
Yeah, that's what I
stuck
would
here.
start with. Things you know for sure.
That's weird.
What does this mean?
As extra coaches too.
So as you get closer to an input of 2, the outputs have to approach 0. So at least you know from that statement, you know where to put an open circle.
I didn't, now I do. So as, so here.
Yeah. And so what I would do is, that means, and do you see how it's not a plus or minus? And since the limit exists, it has to agree from both sides, yes. So I would just put like little whiskers going up that circle, because you don't know what's gonna happen next. So I would just go a little bit out, because I don't know how far, so, like from below, it's supposed to be going to 2, yes. Above it, but I wouldn't go this far. Yeah, you should be drawing functions. So it's gotta be approaching 2, but if I go too far, it might be doing other weird shit over here. Yes, so I just put little feeler lines coming off of that. Little like, one going that way a little ways, one going that way a little ways. It's beautiful, now keep going. Once you get everything kind of set, then you'll know how to connect everything. That problem by itself, if you haven't done a problem with that one, it's not a major issue, but that's a little weird. But I just wanna see what people can tease out of it.
Which is 5.
And what else?
Negative infinity.
Yeah. And that's not from left to right, so it's gotta be from both sides. Where's negative infinity as an output? Yeah. So what's gonna be at 5? Which one going for yourself? Because the output's not 0. The function should be tipping down to negative infinity for both sides. No. Now that's at 6, not 5. So,
Like that? Where's it coming?
from both sides. So I don't know how far to go, but I know if I'm coming from this side, so now I can connect this up. As it comes from this side, it's supposed to be going down here. And as it's going from this side, it's supposed to be going down here. So right here, where you already got the line started, just make it go down to infinity at 5. There we go. There we go. Cool. Yeah, you could even draw the dotted line in, just to make it really clear.
Well, yeah, at 5, the asymptote. Draw on the E.
Once you get the asymptote drawn in, then it's like, you know, Star Wars. It's a drop. You have to pull up and pull down.
I'm afraid the shield generation will be quite hard.
I'm just trying to remember how many of these bits I got because I know we went over that last week about here, but I'm still not quite logically connected. Can you just walk me through how to set this up? I'm not trying something.
When I plug a negative 3 and negative 2.
Yes,
So what can you plot?
When we get the.
No. Let's plot what we know. I know for sure this is true. So what can you put down on your graph? You have an input of negative 3, the output's 2.
It'll just be. Sorry. For some reason it's just.
If you were graphing a function and you made an XY table and you put a negative 3 and you get a 2 out, what could you plot on the
Okay, right. That's what it is. So yeah, it's gonna be it's gonna be if I'm supposed to be.
Huh?
I'm just, sorry.
For an input of negative 3, where's that? Point to an input of negative 3. Input of negative 3, where's the input of negative 3? There, right? Out, yeah, output of 2. Bam! Alright, keep going. Bum, bum, bum.
Yeah, so.
No, go here.
Just.
Yeah.
Just
Plot the stuff you know for sure. No, that's input of negative. Input of 2, yes, good. Now, as I approach 2, my output should go to 0. So you know where there's an open circle. Here, let's take a look at this. How's number 1? Is everybody okay with? Oh, it just kept recording for the whole thing. very exciting part. How number one go? How many places are there discontinuities? 3. All right, so you can see that immediately, right? Only one of them I think could be confusing as to what it is. You might have forgotten the name, but you know kind of what it is, yes? That first one, the name should come to you immediately. So at -3, what kind of discontinuity is there? Jump. What about at 3? This is where there could be some disagreement. Good. Infinite always trumps jump. So this would be infinite. And then what's the other one? 6. What kind of discontinuity is that? Removable. Good.
How is it infinite when it has a point on the line?
Well, you could argue that it's like a jump, but it jumps to negative infinity. So if one side or both goes to infinity, that would be an infinite discontinuity. How big of a jump is this? Infinite. So it's an infinite jump. We just call it an infinite discontinuity. Is everybody with me? I want to give you one that's kind of like feels like 2 different ones. So if you said jump there, I would just put a note. Infinite kind of takes over, dominates. Okay, let me stop for a minute. It's a very strangely defined piecewise function. So pretty cool with that problem right there. So I could give you a problem like what's on the first page, and I could ask you what's the limit as x goes to. I could just combine that with continuity questions, which I do. Okay. Now, this one is not easy the first time you do this. But I wanted to give you a try, and I see everybody getting a little frustrated. On these kind of things, this is a worksheet. It's good to get frustrated to a certain degree because you want to know what you're doing. This one's a little bit tricky. We haven't done one like this together. But I can definitely, those first 3 are points. I can just plot those. Yes? I got my anchor points. So I know at -3, this is supposed to be a 2. At 0 is supposed to be a 0. And at 2 is supposed to be a -1. I'm like, yay! But don't make it a line. That sucks. Now, this says, and this is trippy when you do this the first time, but let me see. Somebody understood this right when I said it, which is beautiful. Bless you. Does it say from one side or the other?
No.
Which means from both sides it's supposed to be approaching. What point is it supposed to be approaching?
0.
No, the output is 0. So what point? That's the input. What point?
2, 0.
2, 0. Thank you. So as I approach the input of 2, I should be approaching the output of 0. So I know I can put it in an open circle at 2, 0. Does everybody see that? Now, if I would have said f of 2 equals 0, would that open circle have been filled in? Yeah, but you can still think of it as, if I see the limit as x goes to something equals this number, I know where to put the open circle. Maybe it's filled in because I already said it's that. You guys kind of with me? That tells me where to put the open circle that it wants to approach from both sides. So when I do this, and you guys have done this, I've seen you guys do this in the air, you just draw that. It doesn't matter. Okay. And I do little whiskers. Okay. By the way, is anything happening between 0 and 2? Is there anything happening between those 2 points? No. So I could just connect. Actually, wait a minute. That's where I gotta be careful. At 0, there's something happening. So let me wait for that. If I keep going this way, the next number is 5 where things are happening, yes? Does it say from one side or the other? So therefore it must be from both sides. And it's supposed to dip down to negative infinity. So what's going to be at x equal 5? Word of glass and toe. You're good. I've already got this started. Nothing weird's happening anywhere else except 5. So now I can take this and do what with it? I'll tell you what to do with it, Jeff. Hey, take it and make it do what it's supposed to do. And what's the only thing I know over here? I know that as I approach 5 from the right, I'm supposed to be approaching the infinity, and then you can make this one do whatever the shit you want it to do, as long as it's a function, yes? Is that the right answer? No. Is it a right answer? All day.
So can you just make this line go, wah? You do other shit you want to, because I didn't say this was doing anything specific over here, did I? You guys understand? It at 5, it better be going to negative infinity. Do I give a shit what it's doing at 6 then? No. Do you guys understand what I'm saying? So if you want to, you could have just made this like a straight line here. I don't care. That's beautiful. That's correct. Do you see how I'm piecing together little local things with what's happening next? So how am I going to put this now? I need to know how I'm approaching 0. Yes? As I approach 0 from the right, that's exactly what this whisker is doing, correct? What am I supposed to be going towards? So where do I put the open circle? Input, output. Where do I put the open circle? 0, -1. As I approach an input of 0, I better approach an output of -1. What about the other side? As I approach 0 from the left, my outputs better approach 1. Where can I put an open circle? 0, 1. And then, so now I know it's like this. I'm just going to go a little bit. You guys see? Just going to go a little bit that way. Is that cool? Do you guys see as I approach 0 from the left, I am approaching 1, correct? Do you guys start to see how to piece these together? Locally, locally, locally connect. Now it's all about what's happening in -3. It's going to tell me what to do with that freaking whisker that I've got coming off the side of that circle, yes? What's happening in -3? I better be approaching what from both sides? 2. Yes? And that's exactly, so if I put an open circle at -3, 2, it's filled in, yes? And I'm approaching it, and am I approaching it? So, which input that I referenced here, -3, 0, 2, 5, is my function continuous through?
Say it one more time.
Do you see all the inputs I reference? -3, 0, 2, and 5. Yes, that's all the inputs I reference. Which one of those is my function continuous through? -3. Why? Because it looks like it's approaching 2, and it gets to 2. Do you see that? Everywhere else, there's a discontinuity. As I have my 5th puberty. There's a discontinuity. What kind of discontinuity is this? Jump, jump. What about this? Removable. What about infant? Okay. When you first look at this kind of problem, I understand it's still very trippy because you have to design your own graph, and you feel like there should be more constrictions, but there aren't, which is kind of scary in its own way. Do you see how I made that squiggly? I don't know why that matters. See how I made a squiggly? Do you have to do that? No. You could have made this like a cubic. I had no restrictions over there, so I have a little creativity. Just don't make it go like this, or else, because then it's not a function, correct?
Well, I guess it makes sense because it's not really your point of focus. It's just how it's interacting with the parts you know.
Yeah, just the individual little inputs. I have specific things that have to happen there. Otherwise, normally what I say is, yeah, I should have put a sketch the graph of a function that's continuous everywhere else or something. Like, you know, it's everywhere else. It actually exists. Okay. How do you guys feel about that? You still look like you didn't like it at all. Could you handle that kind of question better now? Okay, that's like the whole point. So I'll do this every now and again to you. I don't like the way I phrase that, but too bad. I'll give you a problem that's related to what we talked about that we haven't actually done exactly. And then if you don't know how to do it, it's not the end of the world. We're going to talk about it. And then you're going to have to do that kind of thing in the homework. You're going to have to do that kind of thing on a test or a quiz or something. And now you can do it. Did we all get to number 3? Or were we all like not enjoying our time here? Okay. We just did one like with number 3, yes?
So what there's two things I have to look at. What's one of them? What's one area I have to check? Okay, you look at each function. Where do they have issues? He's cool everywhere. Doesn't matter how I define him. He's got a problem where? 0. Is he allowed to be 0? Is he allowed to be 0? Yes. What I mean is, does my domain include that number? Okay. The domain for this piece includes 0. You with me? If this, I need you to understand. If this was here, 0, if these switched, 0 would not be an issue. Do you see that? Because if I put that there, am I even trying to put 0 in? No, then it's cool. What about this?
Well, it can't be negative, so, or it can't be.
The inside can't be negative.
Yeah, exactly. Well, yeah.
What's the smallest positive number I can put in there? 1. So anything below 1 sucks, and where am I starting? 1. Hey! Do you see that? Look at each function compared to what I'm trying to plug in. If I'm trying to plug in a problem thing, that's going to be a discontinuity. What's the other thing you have to look at? So far we got 0, correct? We know it's discontinuous at 0 because of this guy. Poor little guy, he didn't want to be here. What else do I have to check? No?
Where they intersect.
Where they hand off. And where do they hand off? They hand off at x equal -1, and they hand off at x equal. So you got to make sure. Do you guys understand that could relate to this? Where one guy's here and the other guy's looking for the hand off, and that's a jump, yes? As long as they actually agree, that's not a discontinuity. So at -1, where does he want to be? That's almost too easy. When you make x -1, what's x? Holy shit, so the output is -1 here at -1. What's the output here at -1? When you plug a -1 in, what do you get? Holy shit, so did they actually agree? Did they actually get the handoff? Yes, you guys see that. Even if you don't watch relay races and hate the Olympics and all kind of shit, you understand what I'm talking about. Did that one function give it in the right place, or is he over here and this guy's over there? It's like, I get it, in my eyes. Oh shit. What about the last one? Now here's that 1. When I plug a 1 in here, what do I get? 1. When I plug a 1 in here, what do I get?
0.
Oh shit. So it's discontinuous at 1. Good. So where's the discontinuities? X equals 0, x equals 1. For two different reasons. 0 because a function had an issue, 1 because they didn't hand off correctly. Like it? Do you start to understand how my worksheets work? You could do every single one of these problems. Some of them are harder because we haven't done one exactly like the graph that's above this one, yes? It's not the end of the world. You just do as much as you can with it. Because I'm a big believer in how much can you apply what we talked about, and then if you make a mistake and you see the right way to do it, it should even sit in your head better. Because you're like, oh, I did this and I thought it was good, now I know the right way to look at it. You have something to compare it to. Okay. Now this last one, let's do this together. Let me see what time. Oh yeah, she's here at 2:30. I'm gonna let us out a little early to make up for not giving us a break. You guys with me? Is anybody upset about that? No, okay, good. Where does natural log have a problem? 4a. Where does natural log have a problem? Just in general, just natural log of x. Where does this problem start? 0, right? 0's got the asymptote, goes down forever, yes? And what happens when you plug a 2 in? 0. Now, I said 2 from above. Why did I say that? If I would have put a negative up there, what kind of numbers would you try to plug in if you were like making a table of values?
Negative.
No. If I replace the 2 positive with the 2 negative, well, what does a 2 positive mean?
coming from the right. So 2.1, 2.01. What if I would have put in negative? 1.9, 1.99. If I do 1.9 squared, isn't that less than 4? Would I get a negative number? You guys with me? So I had to put 2 from the right. Otherwise, it would have been dead in the water. You guys, or water. You guys with me? Do you guys understand that? That is an extra reason why that sometimes is put, because if we don't put it, it doesn't make sense in the first place. Okay. As the inputs approach 2, what does the argument of the natural log approach? 0. And as natural log's input goes to 0, its output goes to negative infinity. So this is negative infinity. How did I know that? Because I know what a natural log looks like, and I know what it does as its argument approaches 0. As my input approaches 2, the argument, x squared minus 4, approaches 0. And as the argument of a natural log approaches 0, the output approaches negative infinity. So from your perspective, like this. Okay. What can you do with part B? What do you get when you try to plug a 3 in? When you try to plug a 3 in, what do you get? 9 minus 9? 9 minus 18 plus 9 is 0. What's this? What's that tell me? 0 over 0. What's that tell me? Indeterminate. Which means I want to try to do what? Are you here for? What are you here for? That's not quite. I mean, wait a minute. 180?
Yeah.
With which teacher?
Zimmerman?
Oh, I'm not sure where Sierra is right now. That's not this classroom though.
Oh, okay, it's not here.
No, I'm
Okay,
sorry.
Sorry.
You're okay. That's trippy. I'm like, sorry. What do? We're going to have a rational function like that, and it's indeterminate. What is it screaming out to be done? Factor. What do you get when you factor the top? Good. What do you get when you factor the bottom? Yeah, you get x minus 3 twice. So x minus 3 squared, yes? That's right. And then what happens? Cancel one of these out, yes? Now, listen. How am I approaching 3 specifically? From the right. Good. So I'm sneaking up on 3 from the right. So every number I'm plugging in is bigger than 3 with me. Do you see how that really matters here? So every number I'm considering, the bottom becomes what kind of number? Negative or positive? Positive. Number bigger than 3 minus 3 is positive, yes? And of course the top, as I'm approaching 3, is positive, yes? So do you see how, I want to make sure you understand. What happens at 3? Don't I divide by 0? Isn't that some kind of infinity? Now in algebra, you might have said 1 over 0 is infinite. That's wrong. It's either positive infinity or negative infinity, or potentially neither, because they might not agree. And this one, I'm just coming from one side. I need you to see this. Do you see how 3 would make the bottom 0? And you should know that means some kind of infinity. Make it become some kind of infinity. So is it positive or negative? Just what kind of numbers come out? Top is x. I'm getting close to 3, it's positive. Bottom, number a little bigger than 3 minus 3 is positive. So what kind of infinity is the answer? Positive. If this would have been 3 minus x, negative. Because then it's 3 minus number bigger than 3. I'm always getting negatives out. I need you to see this. So the bottom becomes 0 and the top doesn't. It's either going to be positive infinity, negative infinity, or does not exist. Now, real quick. What if I would have come from the left? Then my numbers would have been smaller than 3, correct? You with me? So it would have been a positive thing, close to 3, divided by a negative. So it would have been going to negative infinity, correct?
Yes.
So what if I didn't put a plus or minus at all? From one side it's going to positive infinity, from the other side it's going to negative infinity. So do they even agree?
No.
So what do we say when two limits don't agree? We say the limit does not exist. Yes. You with me? So that is another possible answer. I'm going to let Brandy come up here, give us all a break from the math for a moment. Brandy's going to talk to you guys about the Kick-Ass Success Coach program. Do you want the same, okay.
Hi everyone. How you doing?
They're doing really good.
Are they?
Oh, yeah.
Is he just saying that or?
They're loving
Okay.
me more and more every day. All right. Oh, wait, sorry.
Did you all get to enjoy your weekend?
Uh-oh.
Yes.
We were doing calc homework.
What? Is it because of this guy?
Yeah.
Oh, let me have a talk with him
Right.
after.
Which one of these? Sorry, Brandy.
The middle one.
Middle.
Yeah. Well, I hope, between the calc homework and everything, I know for Professor Waller's kind of rough over here, that you're able to do something to relax or recover from that de-stress and so on. If not, I hope you get a couple of minutes to yourself today to do it. And so my name is Brandy, as he said. I serve as your student success liaison here at Grossmont. Essentially what that means is that I'm here to support you from the moment that you decided to be a student here all the way until the moment you feel you've reached all the goals that you can do here. So my main goal or my main purpose is to make sure that you have the strategies, the resources, and the tools that you need to overcome any challenge that comes your way as a student to be successful in the degrees, the certificates, or the courses that you've set for yourself here. Also, a little bit about me is I was a student here a long time ago, and I came as a student athlete first, straight out of high school, first in my family to go to college, low income, and all of that. And so I spent my first year being an athlete first and a student second. And then my second year is when I discovered what I wanted to major in because I fell in love with the GE. It was not calc, so sorry. So, I tested into business calc. I wish if I would have gone straight to college, with knowledge, I think I would have been a math major or did something with business because it was really easy for me back then. But anyways, I get off track. Communication, so I became public speaking and so on. But I spent 5 years here as a student trying to figure things out, and that's 5 years full time with a very colorful transcript. And the reason why is because as very certain as I was about my major, my path in life, however long it took me to get there, I was also very certain that I knew everything and did not need help. So that's why I'm here today. So I run the Student Success Office here on the campus. If you could help me with the next slide.
Yeah.
My goal is to help you reach those goals a lot quicker than I reached them myself. It wasn't until my last year as a student here that I started to lean in to all of the campus resources that are available, and I started asking questions and meeting with my EOPS counselors and so on. That really put me on track to realize that I took way too many classes or classes that weren't necessary for me and so on. So I hope to be able to connect you with very similar people to leave that imprint on your life. So I like to network and connect with a lot of people. So if you have any questions that's going on campus, like you get an email and you're like, I don't really know what this means. Why is financial aid telling me that I need to petition this? Or, I had this medical emergency with my family and I had to drop the class. I don't know what to do. Or as simple as I want to get involved or I want to figure out internships. I don't know where to go for this. I need help with a counselor. I'm here to help guide you through all of those situations. So we're definitely very well connected on resources. I don't want to just give you a list of all of them or say here's the website. I'd like to get to know you. So if you have time, come and visit. So that way I can start to really narrow it down and personalize a list of resources that would be a good fit for you and that you would benefit from as a student. Skill building, so we do events and workshops throughout campus. Last week was really busy with Welcome Week, and then we're going to be planning some de-stress events coming up later this semester, as well as Study Jam. I know the math department has a pretty killer Study Jam that you all should go to the week before midterms and the week before finals. Lots of free food. But the key thing is, yes, please, you're doing great.
Thank
So, yeah, no problem. Is I want to talk a little bit more about our success coaches. So that's my favorite part of my program, is I get to work with these current Grossmont College students and help develop them become academic mentors for you all. And so you can come in, you can send us an email, you can text us, you can do a drop-in, you can schedule an appointment with one of us. And some really good reasons to come to our office and meet us is to help with navigating the college system. You know, if you're like me, where you're the first one in your family, where it's been a while and you're coming back and you just don't really know where to start or how this thing works, we want to help you through all of that. Connections and community, definitely time management and study skills. I don't know how you all feel about calc and so on, but I'm sure if you want maybe a couple of weeks in, you'll feel either really good or maybe not so, but we're here for that too, all of it. And we can sit down and go, well, where are you spending your time? When are you most productive? How are you feeling at these different parts of the days and so on? Let's look at what commitments you have every week that aren't changing and try to help you build a better schedule. Give it a try. And then if that doesn't work, come back. We'll give you some new techniques and so on. Study skills are really big, but ultimately just making sure you stay on track to meet your goals. So being a student's not easy, life makes it even harder. I specialize with students who are at risk or failing and dropping out. Definitely want to help any student before they even get into that category. And to the next one, so how can you contact us? Here's you could take a picture, because you may not need it today, but you might think of me next week or next month or so on. So you got my email, my phone number's up here. You can contact our office. Here's that email. We're located in a space known as the Village with other support programs. It's also a great space to relax, study, and just hang out. So my office is going to be in building 70 on the second floor in room 202 above the Tech Mall. The Tech Mall is where you're going to get help with your password issues and Wi-Fi. And then you can call us, but you'll probably want to save this number, which is, you could text me. So that 3380 number I recommend. If you're interested in meeting with myself or one of the success coaches, please send me a text right now. We'll get one set up for you. Follow us on Instagram if you like, and try to figure that out. And then the QR code is if you want to be a little bit more proactive, send a little bit of your contact information my way, and we'll reach out. We'll be the first one to reach out and offer that appointment to you. So I don't know if any of you have any questions about anything that I said, any campus resource, parking, anything.
What kills me is if a student needs assistance,
Yeah.
and we have something available, and they just don't even know about it. And the teachers have a lot going on already. I put up their success hub and all this kind of stuff, but we don't have immediate information about each of these things. So, I mean, I need you to understand how insane it is that you can just text or call a person, and their job is to know what all the resources are and what situations actually plug into which resource. It's insane. There's so much stuff that Grossmont can offer their students in a lot of different situations. And to have a success coach whose job is to connect people with those. I mean, good Lord. So, I'm gonna focus on calculus because that's not like my job and with you guys. But you have all kinds of stuff around that's making your ability to do your homework, to keep up with things, so forth, more difficult, correct? So then reach out to these guys. Reach out to me too. I do know some stuff. But these guys, it's their job. It's crazy. Sorry.
No, yeah, that's the big thing is like, if you do have a situation or something that came up and you want to talk about it, it could even help you identify some of those questions to help you advocate for yourself better here at school. So what are those, conversations that you can have with a professor? How can you reach out to them if they're not responding to you and so on? But also like all these different encounters, I don't want you getting ping-ponged from office to office to office to office and so on. So I want to help you figure out like this is the order you should go in, and these are the questions you should be asking at each counter.
So would it be things like resources for food or transportation?
Yeah.
Things.
Absolutely.
Hell yeah.
Because have you all been to the counseling center in building 10? Raise your hand if you've been in there. It's kind of hard, right? It's either a drop in or a long wait, or you can't get an appointment and so on. Very, very busy there. Did you know that there's many other smaller counseling centers available on campus for students? Oh, there you go, see? Sneak peek, come and meet with us. Because we got to figure out who you are and see if you qualify for any of them. Most of them are based, like Mesa is a great program. any student that's required to take Calc 1, you know, ultimately should be looking into Mesa. They
Yeah.
have counselors there too. EOPS has counselors available for students of first generation, students with small children, former foster youth, and so on. And there's many other counseling departments on campus as well to get you connected to.
Cool.
Yeah.
So any questions for Brenda? Anything else? Okay, so it's basically any situation you find yourself in. Contact Brandy's team, yeah.
What were your hours for your office?
I would say Monday through Thursday 9 to 5, and then Fridays 9 to 1. Yeah. Very good answer, yeah.
Of course, you can email anytime.
Yes.
They'll check out whatever they
Yes,
get you.
absolutely.
Yeah, as soon as possible.
Yeah. And then check out the Math Science Center for tutoring.
Yes, Math Science Center. We
So
went there.
Does anyone here have gone yet? Yeah, okay, a few hands. Okay, so you all fit into counseling, so that's good. I'll leave my last thing, if that's okay. Was what I want to give you a new perspective on that spot here. Right, so ultimately when you hear of tutoring, it has a negative connotation. Students feel like, oh, I don't need that because I'm okay. Or that's too stressful, it's very overwhelming for me to get there because how can I go to tutoring without knowing what I'm failing in, and I don't know what I'm failing in because I can't do the damn assignments. Because life is really hard, right? And all and everywhere in between. The Math and Science Center is a wonderful spot to go and study in. And so that would be my fresh perspective that I offer you today, is don't feel like you have to wait until you feel like you don't know something or that you need help to go in there, but rather go in there and check out the space. They got amazing whiteboards everywhere and tables and staff that's walking around. It's right there in the math department with all the math professors and so on. Because while you're studying for this course and while you're doing your assignments and so on and you're getting ready for your exams, that's when you're gonna figure out if you have a question. So why not just do it in the space where someone can help you in that moment? That's my last tip for you.
Yeah. And of course, the Math Science Center is it's led by students, right? All the peer tutors we have, and they've gone through a lot of things that other students, and they're aware of things too, of how to deal with certain things. So that's a good first line defense against that. All right,
Yes.
thank you, Brandy.
Thank you.
Well, thank you for making Mr. Waller stop talking about campus.
Yep,
Is that yours or is that mine? Oh, yeah, that's yours. Okay.
This one's mine.
And let me give you.
I can leave these here if you all want. Yes, okay, perfect.
Bum, bum,
But yeah,
bum, bum.
he's the only one that does that.
What is this? Oh, this one. Yay.
Thank you. Yes. See you
Thank you,
later.
Brandy. See you.
Thank you.
Bye, everyone.
It's so awesome. So let's do this. Let's, I think I recorded that whole thing, which is neat. Let's do this last problem here. And then I'll let us out of here. I do want to say one thing. I think I'm going to go ahead and make section 2.4, I'm going to make it extra credit. I'll talk a little bit about it at this Wednesday's class right after the quiz. So don't forget we have a quiz on Wednesday. Please don't just not come Wednesday if you're not really ready, because you can make corrections to the quiz, right? You don't want to miss lecture. Let's do this one last problem, and then we'll head out. Now, real quick, what catches your eye here that you have to keep in mind? Anything? Do you?
We can CSC.
Oh yeah, so you gotta remember what the hell CSC means.
Yeah, that's the reciprocal sign.
Good. Yes.
It's just the fact that means it's, like 1 divided by sine x.
Good.
Multiplied by x, so it's actually, if you rewrite it, it'd be like x divided by sine x.
That's a really smart idea. So we're normally not as used to cosecant. So why not just go ahead and rewrite it in terms of sine? What's the other thing you have to really pay attention to? Good. It's going to pi from the right. So it's putting angles in that are larger than pi. Yes? So can anyone tell me what quadrant I would actually be in? Bigger than pi radius. Third. Right? Here's from your perspective. Is it from your? Yeah. From your first second, that's pi, third. So yeah, bigger than pi, but I'm gonna approach pi, yes? So I'm gonna be almost all the time in the third quadrant. You with me? What is true about sine in the third quadrant? What's this SIGN? See how it's weird to talk about sine and when you're talking about the sine of the sine?
Sine's negative, right?
Negative, good. Alright, so what's the top? What's true about the top of this? I'm going to pi, so the top is going to get closer to pi. So the top is always positive. And I'm dividing by, now why am I pointing that out? And I should have started with this. What is sine at pi? So isn't this something divided by 0? And it's not 0 over 0, so it's not indeterminate. So what do I know? The answer is going to be some kind of, if I'm divided by 0, the answer has to be some kind of infinity. Now my whole perspective changes. Now I'm like, okay, is it always positive as it goes there? Or is it always negative as it goes there? Because that's going to tell me what kind of infinity. I really want this to make sense. If I plug in something really close to pi, the bottom's getting closer to 0. So the whole thing's getting bigger and bigger and bigger. But if the bottom is always negative as it does that, it's going to negative infinity, correct? Or and if it's positive, going to positive. So what did we just say? Sine for angles bigger than pi is negative. So it's got negative outputs. So the bottom is negative small, and the top is pi, basically. Yes? Now, you don't have to write that. You know it's some kind of infinity, and you just figured out the bottom is always negative as it approaches pi. You with me? So then it's going to be negative infinity. If I would have approached pi from the left, that would have approached pi from smaller angles. Sine would have been positive then, it would have been positive infinity. Okay. Maybe? Screw you, Jeff. I understand. Okay, that's enough. So we'll leave a little early because we didn't get a break. I'm going to be in the CISL lab. I'm going to be in my office for a little bit. I'm going to go ahead and upload the video. But I will be in the CISL lab starting at 3, or in my office right now. So if you want to come see me about anything, go for it. Right here. Always turn your homework in right here. You can turn it in at the beginning of class.